Okay, so digital outputs, high speed. In the case of what we're doing here is, this is how we drive the servo motors or stepper motors. We have outputs, right? And you'll notice that this is a sinking output, unlike a sinking input. Actually, like a sinking. The difference is, you notice that we're supplying power here, and we're syncing the signal to the servo. The servo, these wires connect to the servo, and so the servo's been wired in such a way that it's a syncing output. In the case of the servo, these servo motors, the inputs are usually optical couplers, and the reason they use an optical coupler is so that they can avoid having a surge destroy something, right? And the way the optical couplers work is very simple. The input lights an LED, and the LED activates a phototransistor and turns on the output, but it's actually through a physical barrier, a clear plastic barrier the light is going through. So there's no electrical connection between the input to the PLC or to the drive and the output. So that LED, they actually use two LEDs, reverse polarized, so they'll take syncing or sourcing or even AC as the input. This is a real common technique. That's the PLC, the syncing and sourcing. In the case of the inputs, these are the same thing. These are all optical inputs, back-to-back LEDs. So the inputs are neither sync nor source. They'll work either way. It's the outputs that are the issue, because there's no way to build a transistorized output that can go in both directions. And if you hook them together like you did the input, it'd be a short circuit. So that's why you have to, when you buy a PLC, you have to choose whether it's a syncing or sourcing output. Inputs, never an issue, right? Now, you could also get this PLC with relay outputs, but I stay away from relay outputs because they are mechanical devices and they have fairly limited lifespans. And I've actually had cases where we exceeded the lifespan and had lots of failures. And in the case of what we're doing here, we have no choice but to use solid state outputs, because we're driving high speed outputs to the PLC, to servos. Now, what's high speed? These outputs can go 250,000 cycles per second. So we can, and there's add-on modules that'll go to 1 million. So so why so much? Well, this is step and direction. So the motors we're using, it's 800 steps per revolution of the motor. So in order to make the motor turn 1 revolution, I have to send 800 steps. So you multiply that times how many revolutions you're making per second, and you can see it's a big number. Yeah. So that, now, and the direction one is when you're sending out a step and you're sending out a direction, and this one just goes on and off depending on which way the motor's turning. It doesn't, and we also could use what they call quadrature, where this could be programmed for quad, where it's going both on and off all the time. It's a different kind of thing. Some servos you need quad. So the first 8 on our PLCs, the first 8 outputs are high speed. And so in the case of this job we're doing, we also have 2 add-on high speed modules, because we have 7 servo motors. And the first one can handle up to 3, and each of these can handle up to 3. So, but what we've got is we've got 3 on the main unit and 2 on each of the other high-speed IO units. So this PLC could handle as many as 8 high-speed modules added on to the base. Okay, so now here we have just some basic air valve outputs. This is the valves to open and close the grippers and close the collets on the pipe. and there's one for the head and tailstock, and there's a lube valve because the headstock and tailstock are mis-lubed. So we have outputs to control all that, right? Now, this says digital high speed, and you notice it says module. That's these high speed modules have both inputs and outputs on them. They have 8 inputs and they have 8 outputs, and the outputs can be high speed to 250 kilohertz, and the inputs are also high speed. And in this case, so we're using the inputs on the same module for the home and the ASG, the All Systems Go signal. And the home signal on our, in these, has to be on the same PLC block as the outputs. You can't have them on different, because the home function won't work if it's on like another, if it's in a different module. It's got to be on the same module. So
same module
as the outputs.
As the outputs to drive the servo.
Yeah, right. So if you're using these outputs to drive the servo motor, the home has to be on one of these.
So the function itself, in this PLC's programming language, requires that you be on the same PLC and even on the same module.
Yes.
So those modules are just expansion modules that do the same thing as the inputs and outputs on the main housing, right?
Yes.
Okay.
Yes, and so these just plug on. There's a connector on the end. This particular PLC can handle up to 8 modules of any kind, and so you can get analog and analog inputs. I can get thermal. We have a thermocouple input module that will read 8 thermocouples. There are some high density input modules that'll take 16 inputs, not just 8.